Hey everybody, welcome back to our Franklin Outside episode. And I'm going to turn my camera around because I know that you're seeing my whiteboard as flipped around. So hang with me while we flip our camera around really quickly. All right, all set here. Welcome back again to Franklin Outside. I am your host, Dr. Rachel Dawn Valletta. Dr. Dawn coming at you live from inside today. I had hoped to be outdoors in my favorite local park searching for cicadas, and indeed I have been crawling around on my hands and knees the last few days to find a beautiful specimen to bring to all of you. But here in Philadelphia, we don't yet see any signs of Brood X. So we're going to be talking about the Brood X cicadas today. And so you probably heard my starting sound. I'm going to play it again. Now, some of you might be familiar with this sound, and I want you to share with me in the chat any experiences you have hearing this sound. Right? I associate this with maybe late summer, right? Putting my feet up, having a cool drink, it's hot outside, and this sound can be deafening. And of course, we have probably heard it every summer here in the Mid-Atlantic since past tens of thousands of years. And what we're hearing are the beautiful chorus sounds of the cicada. And indeed, we do have annual cicadas, but you've probably seen in the news a lot of energy around a special periodical cicada. Now, periodical cicadas, including our friend Brood X here, only come out periodically. And so what we're looking at this year is a 17-year cycle of a Brood X cicada, and that is going to be a grouping of a particular species in a particular area. There are 12 broods that happen here on the eastern U.S. Seaboard and inland. Brood X is the largest of those broods. It comes out as far south as Georgia, as far north as here in Pennsylvania, upwards perhaps into New York, and as far west out into the Indiana, Ohio region. So Brood X is absolutely gargantuan, and at its peak, we're going to be seeing upwards of 1 million, maybe 1.5 million individuals per acre. So we're going to be crawling, absolutely crawling with Brood X cicadas very, very shortly. But let's get into what these guys actually look like and talk about how they differ from our annual cicadas. So I'll be using my trusty whiteboard here today. Again, I had hoped to have a hand specimen, but we weren't so lucky here in Philadelphia yet. And there might be a couple reasons for that, and we'll go over that a little bit later on. So what I'm going to venture to do is draw the body plan of our periodical cicada, and the species that we're going to be drawing today is Magicata septendecim. Magicata septendecim. And that literally translates to the magical 17-year-old cicada. All right, so let's go ahead and draw out what this cicada might actually look like. So I do have a little cartoon here to help me cheat, so bear in mind, I'm not a natural artist here, but you may have seen something like this in the past. There we go. All right, gorgeous. So let's start with our body plan here. And I wanted to start with our body plan because it's got a couple weird quirks on it. And so our Brood X cicadas this year are going to be a little bit smaller than our annual cicadas, probably a couple inches in length. So let's go ahead and add a scale bar there. That's about 2 inches tall, okay? And they've got a couple specific features on them. The first that you've probably seen photos are these big red eyes. Now, these gargantuan red eyes are characteristic to the periodical cicadas. Our annual cicadas, instead of those big red eyes, are probably going to have black or brown eyes. And the body of our periodical cicada is going to be this jet black color. Alrighty, so I won't shade in the whole thing, but you can imagine a jet black body plan. There's a couple other really interesting features down on their abdomen, or this bottom portion, looks like their butt, right? It's going to have a couple different segments in it. So let's draw those now. And the reason I point out these different segments is because this is what's responsible for that sound that we've been hearing there. That sound that you're hearing are the male species essentially shaking their rumps, trying to get attention from the female species. And they think it sounds beautiful and like a melodic song, but to us, of course, it can be deafening. All right, so let's take a look here at those components here. Now, what we're actually looking at on the side of the abdomen here is something called a timbal. A timbal, you can write that out there. And I like the word timbal because it kind of sounds like cymbal, and it's reminiscent of that sound that they make, all right? And that's what's actually shaking. So the abdomen muscles are going to pull that butt side to side, and it's going to make that sh, 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 sh sound. All right, so that's what's responsible in the males for that big loud sound we're hearing, or the timbals. Think about cymbals. Okay, so kind of a gross body plan so far. Why does it look weird? Well, we haven't, of course, added the wings. Now, what's interesting about our periodical cicadas is they've got these really characteristic, you can kind of draw them like this, not my best. They look kind of reddish orange, all right? And they're going to have venations throughout them, all right? Something like this. Alrighty, and on the periodical cicadas, again, these are kind of a red-orange color, very characteristic of our 17-year cicadas. Now, they don't really fly too much. You've probably seen them fly short distances, but they're not going to migrate very far. And this I find absolutely fascinating about the periodical cicadas. They start in the ground, that's where they're hanging out for 17 years, and during that time, they're just sort of chilling. They're in a state called a torpid state, and that means that they're super, super low energy, the absolute lowest energy state you can imagine to keep the critter alive. But that whole time, it's still growing, and it's feeding off of fluids that are coming out of tree roots. And those little tiny underground nymphs are going to be buried 1 to 2 feet below our feet for 17 years, sucking up the xylem fluids from tree roots. It's actually pretty low nutritional value, but that's how they make it work for them. Now, once these critters are ready to come out for their 17-year cycle, they're going to make their way towards the shallow soil surface. And once they get there, they're going to wait for the absolute perfect soil temperature to emerge. That absolute perfect soil temperature is what is going to tell all of the individuals that the party is on. And it is very, very precisely 64 degrees Fahrenheit. So the reason we perhaps haven't seen them yet here in Philadelphia is because we haven't had enough warm days in a row to bring that soil temperature up warm enough. Okay, so they're waiting for the absolute perfect 64 degrees. That's when it's ready to scoot on out. They'll get closer and closer to the soil surface. And sometimes in emergence zones, we'll see these mud volcanoes. Now, these are really, really cool streaks of sediment that's been built up off the ground. They can get about 1 inch high. And what we're actually seeing are cicadas moving vertically up and down in response to heavy rains. This is really, really rad. So they occupy a tunnel in the shallow subsurface. When it rains, of course, that tunnel fills up with water. And so the cicadas come upwards to basically still have access to air. When the rain waters recede down into the subsurface, into the deeper soil layers, they go back down again. And this motion up and down is what creates that mud volcano. So if you see around the base of a tree, these small holes, about 1/2 inch, maybe 1 inch or so in opening, with concave sides on their edges, it could be where a cicada emerged. All right, so eventually they're going to come up out of the ground. And when they come up out of the ground, it's going to be a little bit later in the day. They want to avoid all prey, and they're going to seek out the nearest tree. And they're going to seek out the nearest tree because they want to climb up it, of course. And here's how this goes. You may have seen cicada exoskeletons in the past that are sort of clenched onto trees. And indeed, it all starts with this process. Cicadas emerge, they come up the nearest tree, they latch on to the bark, and now the baby, essentially the nymph, is going to transform into the adult. Now, we won't be showing any videos of that today because for those of us that are squeamish out there, we might not want to see that before lunch. But what's going to happen is that nymph is going to latch on to the edge of the tree. It's going to break open its back, and the adult is going to emerge from the back of the exoskeleton. This is totally rad movie stuff, guys. Super, super cool. When the adults first come out, they're going to be this creamy, milky white color. And they don't take on this beautiful black and orange and bright red coloration for a few hours yet. When they first emerge, they're going to be really, really soft. And their wings are going to be rolled up on their back. So over the next few hours, the adult cicada is going to hang out next to its recently shed exoskeleton. It's going to unfurl those wings as they start to pump full of blood. It's going to start to harden its exterior, and it's going to enter into its adult life stage. And this is what it's all about. For the next 2 to 3 weeks, the only purpose that these adult cicadas have is to sing a song and to mate. They're not going to do anything else. They're not going to eat. They're not going to sleep. They're simply there to make babies. So shortly thereafter, we're going to start hearing these timbals. Remember, sounds like cymbals. We're going to hear that butt shaking, and those are the males seeking out females. And eventually, we'll find a female that likes the song. They will mate, and they'll eventually lay those eggs on some tree limbs. But that's the long and the short of what the periodical cicada is really waiting for. It's hanging out underground for 17 years, and it's just going to come above ground to mate and to sing a song for a few weeks, and then it's going to die. So it's lived a short life, it seems, but actually that 17-year age is one of the longest on record for any insect, which is pretty extraordinary. Now, once the females do fertilize the eggs, they're going to use a special spike on the bottom side of their abdomen. Now, we haven't drawn it here. We've actually, by indicating the timbals, we've drawn a male species here. But on the underside of the females, just about here, again, down near the tip of their butt, they've got a small spike that's going to extend downwards, and it's going to pierce under tree bark. So they're going to look for soft tree bark out towards the end of branches, and under that tree bark, that's where they're going to lay their eggs. Alrighty? Once they lay their eggs, it takes a few months, for those eggs to hatch, and eventually, once they hatch, they fall back down to the soil surface, and they start this process all over again. And that's the long and short of the life cycle of the cicada. So, any questions about that, go ahead, drop them in the chat. Remember, I love to hear about your personal experiences of these cicadas. Was anyone around for the last 17-year emergence? I'd love to hear about that. And we do have a question here. Somebody asks, will they damage our trees and shrubs? That's a fabulous question, and indeed it's something a lot of folks worry about, especially when we hear that there's going to be billions of these guys roaming around partying on our lawns and our backyards. Turns out, no. Both annual cicadas and periodical cicadas are completely harmless to humans and for, let's say, 99% of our vegetation. Here's why. They can only potentially damage a very, very young tree thanks to that piercing mechanism I just mentioned on the female. So again, that female's piercing mechanism is only about this big, probably less than the size of your pinky nail if you hold that up. And for younger trees, if there are hundreds and thousands on an individual tree that are all piercing it simultaneously, there could potentially be a problem there. So, for those gardeners out there, if you just put in a sapling recently this spring, maybe you celebrated Mother's Day with a planting event or with your neighborhood, you're going to want to cover that with a net. But we're talking really tiny saplings, so like 5 feet or shorter. The vast majority of your trees are going to be completely unaffected. Remember, these aren't locusts. They're not here to come out in waves and eat up our crops and move along. They're just here to sing and to mate. They don't really care about our vegetables. And thank goodness for that. Another question. Why are there more periodical cicadas than regular cicadas? I love this question because it really gets at the root of an evolutionary biological mechanism that these cicadas have been able to take advantage of. Now, that was a big, long phrase, so let's break that down. Of course, when I talk about evolutionary biological mechanism, I'm talking about something that has developed over millions of years. Now, these cicadas have figured out how to overwhelm their predators so that they can lose some of the individuals, but they don't all die off. Now let's talk about why that is really, really interesting. Alrighty, so these species, as mentioned, there could be upwards of 1.5 million per acre. Now the very, very first individuals of that 1.5 million per acre are males. So there are more males that are hatched than females. And the early emerging males essentially sacrifice themselves. And what they're doing here is something called predator satiation. There are so many cicadas that they literally overwhelm all of their predators. There's so many out there that squirrels and birds and raccoons and all of the other wildlife that are seeing them are going to gobble them up, and they're just going to get full. They're just going to fill up on all of those soft-bodied, remember, recently hatched adults. And indeed, these are very easy to eat. Humans can eat them. You can cook them up in eggs. I've seen some great recipes out there. I've heard they taste like raw potato or raw vegetable. But if anybody wants to send along a recipe, that's definitely something I'd be interested in trying out. So yes, indeed, a lot of them do die off. But what they're doing is they're sacrificing individuals for the sake of the whole population. So a whole bunch of men sacrifice themselves, and eventually more come after in the following days. All of the birds and all of the predators in the area are full up. They're less interested. And so the cicadas can go on with their mating cycle undisturbed. So yes, you can eat them. And I see another question here. What happens if my dog eats them? Dogs can eat them too. No harm there. Alrighty. So predator satiation. That's called a wonderful evolutionary tactic so that the species can continue to propagate, continue to survive. We have a comment here. I heard that broods are dying out. Why are broods dying out? That's an excellent question, and there may be a couple reasons for this. The number one impact, and this is not just on cicadas, but a lot of other insect species, has to do with human development. So I mentioned that these guys are hanging out underground for 17 years. Other periodical cicadas are hanging out underground for 13 years. Now, imagine if you live here in Philadelphia or another town, imagine over the course of 5, 10, 15, 20 years, the development that's happening in your neighborhood, that's happening in your cities. What's happening there? Houses are being built, right? We're laying down ground. Perhaps we're replacing forests and wooded areas with new roads, highways, etc. All of this development can have a negative impact on the broods that are hanging out underground at that time. We're literally capping them off, right? And so for that reason, we're probably seeing less insects, or rather periodical cicadas emerge in urbanized areas like Philadelphia, because there's just been too much development. Other impacts that cicadas can feel perhaps have to do with changing temperatures. And no surprise, this is an area of active research, but we know that increasing temperatures can have a negative impact potentially on periodical cicadas. Now, periodical cicadas have been known to come out in cycles that differ from every 17 years. And they can do this on purpose in response to a temperature change, a fluctuation, or they can do this accidentally. They can get confused. There's a recent case study, I believe from the Cincinnati, Ohio region, that documented a 17-year periodical cicada that came out a year early. And here's what happened. In some of the preceding winters, there was a particularly warm winter. And it got so warm that the trees in the area started to bud. And when they bud, that's when actually all of that xylem fluid is pulsing out of the tree roots. And the cicadas are keeping that 17-year clock by counting. We don't know how, but somehow they count and keep track of those pulses of growth from the trees. That's what's telling them that a year has passed, another year, another year. So in this particularly warm winter, we saw temperatures that were so warm, mid-60s, low 70s, trees started to bud, and it was followed by a hard freeze. And then spring actually did come on and got warm again. So there was a second pulse of growth. The trees started to bud again. But imagine if you're the cicada underground, the only thing that you have keeping track of those changing seasons are the pulses of that xylem fluid into the roots. So in a single year then, that particular brood in the Cincinnati, Ohio area saw 2 pulses in 1 year. So it was 2 for the price of 1, essentially. And indeed, we saw that they came out a year early. So it's wonderful evidence, a wonderful anecdote, that they are actually counting these annual cycles so specifically. But of course, also it's telling us that changing temperatures, perhaps impacts of climate change as well, could be having negative impacts on those species coming out early. What happens in that case, one last point there, is many of those species that come off of their cycle, if they come early or they come late, they are a part of that early feeding frenzy that predators perform. And so remember, we mentioned that part of the reason that Brood X is so successful is because of its great size. So many come out that a bunch can be eaten, and there's still a bunch left. There's still millions left that can mate. But imagine now if only a small secluded area gets that 2-season impulse and comes out early. Well, they come out early and they get eaten up, but the others aren't getting that impulse. So they come out early, but they can't successfully mate and create new nymphs to go through that 17-year cycle again. So indeed, human development and deforestation can have a really, really big impact on broods along the eastern United States. And climate change, we may be starting to document, is affecting negatively those cycles as well. Fabulous. Another question. How far underground are they now? That's a great question. If you're in the Philadelphia area, fingers crossed, I'm waiting to see the cicadas. Although, as I understand it, we missed out largely on Brood X 17 years ago. There might have been some spotty instances and occurrences, but largely we missed out on that. Again, probably because of pretty heavy development in the area. But in the surrounding rural regions, if you're calling in today from the ex-urban or the quasi-rural areas outside of the city of Philadelphia, and especially our friends down in Maryland and Delaware, perhaps southern New Jersey, you might already be seeing these guys rearing their beautiful big red eyeballs at you. But in the immediate Philadelphia area, they're probably just in those last couple inches. And they're waiting for one last signal. We didn't mention this yet, but right before they make their last crawl out of their tunnels, they're likely waiting for a rainstorm. So warm days like this week here in Philadelphia, followed by a rainstorm, are the last push that really get those cicadas up and up into the trees. So if we see a heavy rain, we could be looking for cicadas shortly thereafter. So keep an eye out for that. Do cicadas do anything good for the environment? That's a fabulous question. And I've looked a bit around for this, and there doesn't seem to be an extraordinary amount of literature into this. Now, where they do benefit the environment, remember, they grow and perform their entire life cycle all within the vicinity of the same few trees, right? And surely because of the number of them, they contain nutrients. Their bodies contain nutrients. They grew, they ate, right? And so when their bodies die off, they return all of those nutrients back into the soil. So an individual cicada might not pack a whole punch, whether it be for us or for the tree, but imagine now millions of those. And again, I would love to hear personal anecdotes for those of us that have seen a periodical cicada emergence before, because when these guys die off, they really die off. And we're talking about big mounds of cicadas that can decay in the vicinity of a tree. And so perhaps that could be a positive environmental impact by the cicada. All right, got one last question here, and then we'll wrap it up. So any other burning thoughts, go ahead and throw them into the chat, and my colleagues will pass them along here. We have a question, can they be composted? Yes. Absolutely, cicadas can be composted. Now, it turns out that their exoskeletons are probably going to be pretty crunchy. So for those gardeners out there, you know that sometimes you need to do a little bit of preparation. You might want to ground them down a little bit first, but absolutely remember that they grew up on root exudates. Exudates. There we go. Got stuck on that one. So anything that the tree is feeding on, that's what these cicadas are feeding on. So if you can compost tree materials, you can compost these cicadas. So not huge nutritional value, but you can definitely do something with their bodies that are hanging around. We have some more questions coming through, so we'll just wait one more moment. And while this next comment is coming through, I'd like to just note something really, really intriguing, and it has to do with the distribution of the broods. So we're talking about brood X, and I didn't even explain that X, of course, stands for the Roman numeral 10. There are 12 different broods that come out periodically, either a 13-year or a 17-year cycle here in the eastern U.S. And those broods all occupy very specific geographic regions. And where they first got their start, basically where they put down roots, goes back all the way to the last ice age. When we were coming out of our last ice age, about 12,000 years ago here in the Northeast, the last glacial maximum, which basically means the furthest southern extent of the last ice sheet that existed here in North America, came down to roughly here in Philadelphia, a little bit further north. But eventually it started to recede. As the climate changed, it warmed up, that ice sheet receded northward. And after the ice sheet receded, remember this happens over thousands of years, it receded northwards, and as it receded, forests moved northwards back to where the ice sheet was, and once the forests moved in, the cicadas followed. So the different broods have all popped up periodically where they are, thanks to the influence of where the ice sheet was. So this is a really, really cool relationship here we're seeing between the climate and geology, essentially, and biology as well. So really cool story there. Broods are where they are thanks to where the ice sheets were 12,000 years ago. Okay, we did have a comment come through. Someone says we're really going to get slammed by these bugs this summer, and we could. Again, here in Philadelphia, waiting to see if that's the case. But for those of us calling in from the surrounding areas, you may be in for a big cicada slam. So get out there and enjoy them. That's one thing that we want to, share with all of you. They look like big ugly bugs, especially my drawing here, perhaps, but they should not be feared. They may sound very, very loud. But other than that, this is a natural wonder. We don't often get to see these spectacles so generally out in the open where we live. But here in the Mid-Atlantic, we are going to have a chance to see that. And I mentioned there how loud they are. I read a fabulous factoid, which absolutely knocked me off my feet. These guys can get up to 90, 95, 100 decibels. That's comparable to the sound you hear in a rumbling subway car, or if you're close to a loud lawnmower. All right, so they can get absolutely deafening. So it is valid. If some folks have heard these before and they're not looking forward to it, it has been loud in the past, so it could be loud if you're in an area where that chorus is so loud. But remember, it's only going to last 2 or 3 weeks, so don't feel obligated to try and swat them away or kill them. You probably won't be able to get to them all anyway. We did have another question come through. Are there cicadas on the West Coast? It's a fabulous question. There may be individual annual cicada species, but not periodical cicadas. And when I said that this was an amazing natural wonder, it is truly unique to the eastern U.S. And certainly the density of the broods that we have available to us and in our areas that we get to see come out periodically on these 13 and 17 year timescales. Now, there have been other documentations of periodical cicadas in the Southeast Asian region, but nothing to the extent of the East Coast broods, and nothing to the extent of Brood X. Brood X really is what the cicada mania is all about this year, because it's the biggest and the baddest. Another question here. What do we do to prevent them without hurting them? I don't want them flying or coming near me. Help! Well, unfortunately, you'll probably have to hang out for a couple weeks inside. It's true, a lot of us are nervous around bugs, and that's okay. That's okay, but these guys aren't going to hurt us. They don't bite, they don't sting, and in fact, you could eat them if you wanted to, and though it sounds like this viewer might not be so interested in that. The best thing to do is to really just get out of their way and let them do their thing. It's only going to be 2 or 3 weeks, and I know that can be frustrating because we've all been sequestered in our homes for so long now, but hang out just a little bit longer and let nature run its course. Though I suppose you could always set your dogs outside to eat up some of the really, really heavy infestations if you like. And I said infestation there, but really we shouldn't say infestation. Remember, we're sort of occupying their original habitat and not the other way around. So we got to be friendly with our insect neighbors. Alrighty, so we're slowing down here in the chat, and I think we've covered just about everything I wanted to get to today. So if you are in an area that is seeing periodical cicadas, please send me photos. Remember, I have been out crawling on my hands and knees looking for evidence of those mud volcanoes. And if you're interested in looking for the early emergence, the very, very first night of soil exit for these critters, you're going to want to do it in the dusk time of day. They come out as the sun is setting to avoid daytime predators. And when they come out, they will come out in droves. Keep your eyes out. If you see them in Philadelphia, let me know. Please send us a message on Facebook. I would love to come and snap a photo. But for those of you out there that are interested in documenting where these species are coming out, you're going to want to check out a really cool citizen science app that I've come across. And we're going to put this comment into the chat for you here. And the full name is, let me pull this up. Here we go. It's called Cicada Safari. So you can download this app. It's for free, iPhone, Android, all that. I've got it on my camera. And what you can do is you can help scientists document the abundance of these cicadas that are emerging in Brood X and their geographic distribution. Remember, entomologists, those are bug doctors, are always trying to track how bug populations are changing. Are they growing? Are they shrinking? Are they being impacted by certain human behaviors or certain human development? We want to be able to track that as scientists. And we love making sure that our TFI audience gets opportunities to engage with that. So go ahead and check out Cicada Safari. Snap a photo of any cicadas that you see in your neighborhood and share those stories with us. We'd love to hear about your experiences. I think that does it for us today. Remember, I'm Dr. Dawn. It's been an absolute pleasure talking about Brood X with you all today. And I'm going to hit some cicada music to sing us off here. Everybody have a fabulous afternoon. Snap those photos for me. See you soon.